Hello, my name is Nguyen, and I'm presenting my work on robot object retrieval with contextual natural language queries. Natural language object retrieval is an important skill for robots in human-centric environments. In real-world situations, robots are bound to face unknown objects or unknown words from open-ended language commands. For example, a robot can be presented with these 5 objects and asked to bring me the outside. The robot is likely to never have seen any of these objects before, nor does it know the word outside. However, we want our robots to be robust and still be able to handle such situations. Unfortunately, the majority of previous work focuses on handling language commands that directly specify objects' attributes, such as red, has handle, or the object class, such as cup, and thus their models cannot handle unknown words and object classes. Our work is built upon the observation that people usually ask for an object with a specific use in mind, such as a cup for drinking or a rolling pin to roll dough. We focus on handling commands requesting objects for specific uses, such as bring me the outside to wear in the previously given example. Our model utilizes the context provided by the intended use to identify and retrieve the desired object, such as the red dress in this case, and can handle unknown nouns and object classes. Given a language command and candidate objects to choose from, our model generates embeddings for the command and objects and selects the object that is closest to the command in embedding space. Our model consists of separate image and language encoders. During training, we minimize the cosine embedding loss between the embeddings generated by our encoders to maximize the likelihood of the target image given the language command. We train our model on pairs of natural language commands and RGB images. Each language command contains a verb to specify the object's use. We collected our own dataset, which has 655 verb-object pairs, over 50 verbs, and 216 object classes. We held out 20% of the object classes to evaluate our model. The evaluation task is to retrieve the correct object from a set of 5 candidates. The model assessed it on entirely unseen object classes. On this task, a random model would achieve 20% top 1 and 45% top 2 retrieval accuracy. Our model achieves 62.3% top 1 and 80.2% top 2 retrieval accuracy on unknown object classes. In the case of unknown object classes and unknown nouns, our model achieves 53% top 1 and 72.8% top 2 retrieval accuracy. We also conducted an experiment on Amazon Mechanical Turk to establish a human baseline on this task. We showed AMT workers 5 images and 1 language command and asked them to select the image with the object that best satisfies the command. The average top 1 human retrieval accuracy is 78%. Our model did not achieve human level of performance, but still demonstrated generalization on unknown nouns and unknown object classes. We also tested our model on the YCB object set, a dataset of objects commonly seen and interacted with by robots. Our model achieved a retrieval accuracy of 54.7% for top 1 and 71.9% for top 2. We did not retrain our model on this dataset, so this shows that our model was able to generalize to a dataset with a different image distribution. These results are not perfect, but they enable the robot to reduce its search space and can employ strategies such as question asking to further disambiguate and retrieve the correct object. We implemented our model on a KUKA robot arm, enabling the robot to retrieve objects based on descriptions of their usage. The robot correctly selected the t-shirt for the task of give me something to wear. When asked to give me an item that can write, it was able to pick out the marker from other distracting objects that are also partly red and have slim bodies. Next, it accurately identified the pear and Pringles strip scan as the top 2 items that would satisfy hand me something to eat, and ultimately picked up the pear. This is the only test case with more than 1 possible correct answer. Finally, when asked for an object to contain, the robot selected the empty minion-shaped bottle. To summarize, our contributions are a model to retrieve objects based on descriptions of their usage that can handle unknown nouns and object classes, a dataset of 655 verb-object pairs denoting object usage, and demonstrations of our model on a robot. Thank you for listening, and if you have any questions, Please come to the discussion session for the paper or email me.